Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the details about the types of flip-flops. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to start the second unit named as Shift Register and Counters. Let's see the introduction of shift registers. The flip-flops can be used to store a single bit of binary data 1 or 0. That means we know that the flip-flops are used to store a single bit of binary data, usually 1 or 0. Okay. However, in order to store multiple bits of data, we need multiple flip-flops. For example, if we want to store this data 1 1 1 0, then we require total 4 flip-flops here. Okay. N flip-flops are to be connected in order to store n bits of data. A register is a device which is used to store such information. That means to store this information we require 4 flip-flops, and the 4 flip-flops are known as the register. Okay. The register is a group of flip-flops connected in series used to store multiple bits of data. That means, in other words, we can say that the register is a combination or the connection of a flip-flop which are connected in series to store n bit data. And for n bit data, we require n number of flip-flops. For 5 bit data, that means for 1 1 0 1 1, there are 5 bits, hence we require here 5 flip-flops. Okay, I hope you all understand. Now let's see what is meant by the shift register. The shift register is a group of flip-flops used to store multiple bits of data. The bits stored in such registers can be made to move within the register and in or out of the register by applying the clock pulses. That means the shift register is used to store the data, and in this shift register the operations like input or output are synchronized with the clock pulses. Okay, that means the shift registers are operated on the clock pulses. An n-bit shift register can be formed by connecting n flip-flops where each flip-flop stores a single bit of data. The shift registers basically consist of D type of flip-flop or latches. This is the very important point here, that in shift registers usually D type of flip-flops or latches are used. Okay. Now let's see the types of shift registers. Generally, there are 4 types of shift registers. First one is serial in, serial out, that means SISO shift register. In this type of shift register, the data enters in serially and taken out serially. Okay. Further, SISO is divided into 2 types. We will see it later. The second type is serial in, parallel out, that means SIPO shift register. In this type of shift register, the data enters serially and taken out parallelly. Okay. The third one is parallel in, serial out, that means PISO shift register. Here data enters parallelly and taken out serially. And the last one is parallel in, parallel out, that means PIPO shift register. Here data enters parallelly as well as the data taken out parallelly. I hope you all understand the 4 types here. The 4 types are, let's see once again. The first one is SISO, that means serial in, serial out. Second one is SIPO, serial in, parallel out. Third one is PISO, parallel in, serial out. and fourth one is PIPO, that means parallel in, parallel out. Let's see the first type, serial in, serial out first. The SISO shift register is of two types. The two types are, first one is serial input, serial output, left shift mode. Okay, that means in this mode the data shifted from left to right. Okay, second one is serial input, serial output, right shift mode, like this. Okay, let's see. First type is serial input, serial output, left shift mode. In this mode the data bit shift from right to left, that means right to left, by one position per clock cycle. We already seen that for this type of shift register we use the D types of flip flop. Okay, that means these flip flops are of D type. Okay, here we want to store 4 bits, hence we used the 4 flip flops here. Okay, this is the logic diagram here. In this logic diagram we can see that each flip flop has the data input and output. Similarly, it has data input and data output, input and output. Okay, now let's see more details about this diagram. In this diagram we can see here that the clock's signal is connected with each flip flop separately. That means the clock is connected here, this connected here, this is connected here. Okay, now let's see, we are going to illustrate the entry of 4-bit binary number 1111 into the register. That means in this register we are going to enter the number 1111. The number should be applied to D in bit by bit with the MSB bit applied first. This number is applied to D in where the MSB, that means this one, is applied first. Okay, the D input of the flip flop 0, the D input, let's see once again, the D input of the flip flop 0, that is D0, is connected with D in. Here D0 is connected with D in. Okay, we can see here the output of flip flop 0, this is the output of flip flop 0, is connected with, that is Q0 is connected with the input of next flip flop D1. Okay, and so on. That means the output of flip flop 1, that means Q1, is connected with the input of flip flop second. Similarly, the output of flip flop second is connected with the input of flip flop third. I hope you all understand the connections here. Now let's see the operation here. Initially, that means in starting condition, all the outputs has the value 0 0 0 0. Okay, let Q3 has the value 0, Q2 has the value 0, Q1 has the value 0, and Q0 also has the value 0. This is the initial condition. Now apply MSB bit of the number to be entered to D in. We have to enter the data 1 1 1 1. This is MSB, and apply this MSB to the data in bit. Okay, so the data in or D0 is equal to 1. Then after the application of the clock on the first falling edge of the clock, flip flop 0 is set and the stored word in the register is 0001. Okay, I hope you all understand the operation here. Let's see once again. We want to enter the data 1111 in the shift register. Initially all the flip flops are in reset condition, hence they has the value 0000. Now apply MSB, that means 1, to the data in. Okay, hence data in or D0 now becomes 1. Then after the negative edge of the clock, what happens, the flip flop 0 sets, hence q0 becomes 1 while other has the value 0 0 0. Then after application of the first clock, we get the data 0 0 0 1 in the shift register. Okay, now apply the second bit to D in 1 1 1 1 1. This is the data we want to set. The first is already applied, then apply this one. This one is connected to D in. Then what happens, the flip flop 1 sets, hence q1 becomes 1 and the data becomes 0 0 1 1. That means 0 0 1 1. Okay, apply the next bit to the stored, that is 1, this one, to D in. What happens in this case, after application of third clock pulse or the third negative edge of the clock, the flip flop 2 sets. Here the flip flop 2 sets, hence it becomes 1 and the data becomes now here 0 1 1 1. Okay, then after application of the fourth one to the data in, the flip flop 3 sets and it becomes the data 1 1 1 1. The data becomes 1 1 1 1. I hope you all understand the operation here. Let's see once again. Here we want to send data or store data 1 1 1 1 into the shift register. First apply this MSB to the data in. Initially all the flip flops are in reset condition, hence they has the value 0 0 0 0. After application of the first bit of data or MSB to the data in, the flip flop 0 sets, hence we get the data 0 0 0 1. Then apply the second bit to the data in, then at the negative edge the flip flop 1 sets, hence we get the data 0 0 1 1. Then apply this third bit to the data in, then at this time flip flop 2 sets, hence it becomes 1. Then our data becomes 0 1 1 1 and at the application of the fourth bit to the data in, we get the flip flop 3 is in set mode, hence we get the data 1 1 1 1. I hope you all understand the operation clearly. The operation of shift register can be clearly understood by this truth table. In this truth table, we can see here that this is the clock Q3, Q2, Q1, Q0 and data in. We know that at initial state all the output has the value 0 0 0 0. Now we want to enter the data 1 1 1 1. Hence first connect or give MSB to the data in, that means this one, we get the flip flop 0 sets, hence Q0 becomes 1. Then after application of the first clock pulse, we get the data 0 0 0 1. At the second clock pulse, the flip flop 1 sets, hence we get the data 0 0 1 1. At the third clock pulse, we get the data 0 1 1 1, and at the fourth clock pulse all the flip flops are in set condition, hence we get the data 1 1 1 1. Okay, this operation can be verified or can be seen on the timing diagrams. In this timing diagram, first signal is of clock signal. We know that The clock signal is a perfect square wave having 50% duty cycle. Then the data in, this is the data in, and it is 1111. Okay, now our shift register is response only for the negative edge of the clock, hence only at these positions the output of the shift register is changed. Now let's see the first arrival of negative edge. When the first negative edge occurs, at this time data in is 1. Here the q0, only the q0 sets, hence at this time q0 becomes 1. Okay, then at arrival of second clock pulse the q1 is set. At arrival of third clock pulse q2 is set, and arrival of fourth clock pulse q4 is q3 is set. I hope you all understand this timing diagram now. Now let's see the serial input, serial output, right shift mode. Here in this shift register, the data bits shift from left to right. That means left to right by one position per clock cycle. The diagram is very simple. In left shift mode, the input is given here, while in right shift mode, the data in is connected here. Okay. Then here also we are going to illustrate the entry of 4 binary numbers or 4 bits 1111 into the register. The number should be applied to D in, that means to D in, bit by bit, with the LSB bit applied first. In left shift mode we apply MSB, but in right shift mode we have to apply LSB. The D input of flip flop 3, that is D3, is connected to D in. D3 is connected to D in. The output of flip flop 3, that is Q3, is connected to D2. Similarly, the output of flip flop second is connected to the input of flip flop 1. Output of flip flop 1 is connected with the input of flip flop 0, and so on. I hope you all understand the connection of the right shift mode. Now let's see the operation here. The operation is similar like left shift mode. At initial condition, all the flip flops has the value 0 0 0 0. That means all the outputs are at 0 0 0 and 0 state. Okay. Then apply the clock, that means application of first negative edge of the clock or the falling edge of the clock. The flip flop 3 is set, and the stored word in the register is the flip flop 3 is set, hence it becomes 1 and the word becomes 1 0 0 0. Okay, I hope you all understand. Then at the application of second clock or the arrival of next falling edge or negative edge of the clock, flip flop 2 will be set, hence the data becomes 1 1 0 0, that is 1 1 0 0. Then after application of the third clock, the data in is 1 and hence we get the data. Now flip flop 1 is set, hence the data becomes 1 1 1 0. And similarly at application of fourth bit, that is 1, and the application of fourth clock pulse, we get the data. Flip flop 0 is set, hence the data becomes 1 1 1 1. Okay, the operation is very simple here. I hope you will understand it. Let's see the truth table here. Initially the data is 0 0 0 0. Then after application first falling edge of the clock, flip flop 3 sets, hence the data becomes 1 0 0 0. at the application of second clock pulse, the flip-flop 2 sets, hence the data becomes 1100. At the application of third clock pulse, the flip-flop 1 sets and the data becomes 1110, and at the application of fourth clock pulse, the flip-flop 0 sets, hence the data becomes 1111. Here the difference is that here LSB apply first, while in left shift operation the MSB applied first. Okay, this operation can be seen on this timing diagram. Okay, this is the timing diagram in which the clock is represented with a square wave and the data in is 1111, that means high all the time. Okay, we can see here the output changes with the negative edge of the clock only, that means the falling edge of the clock only. Then at the first falling edge of the clock, the flip-flop 3 sets, hence Q3 becomes 1. At the second falling edge of the clock, the flip-flop 2 sets, hence Q2 becomes 1. At the falling edge of the third clock, the flip-flop Q1 sets, hence Q1 becomes 1. And at the fourth falling edge or the fourth clock pulse, the flip-flop 0 is set, hence Q0 becomes 1. This is the timing diagram for the right shift register. I hope you all understand the operation of serial input, serial output, left shift mode and right shift mode shift register. Thank you.